A very good afternoon, everyone. I'm Swaroop, the marketing head at Steer World, and I'll be your host for today. Firstly, I would like to thank all the participants for joining us on this webinar on going beyond traditional compounding and revolutionizing color masterbatch processing. Before we dive deep into the session, a quick introduction about Steer World. Steer is a global leader in the twin screw extrusion platform technology, providing solutions in the fields of plastics, polymers, recycling, food, pharmaceuticals, nutraceuticals, and biomaterials. In today's webinar, we will explore how wet cake pigments can revolutionize pigment dispersion and polymer quality during compounding. Our experts will provide key insights into the future of color masterbatch processing and how you can leverage these advancements for superior masterbatch performance. Before we begin the session, a few quick guidelines to ensure a smooth session. The webinar is for a total of about 90 minutes, including Q&A at the end. You are always free to post your questions or comments during the webinar in the chat box, and our experts will answer them during the Q&A session. And now, a quick introduction about our speakers for today. Our first speaker for today is Dr. Prakash Hadimani. He's the Global Head of the Application Development Center at Steer World. He holds a PhD in Polymer Science and Technology and has contributed extensively to the field through patents, research publications, and international conferences. With over 20 years of experience in polymer processing and characterization, Dr. Hadimani is a leading expert in co-rotating twin screw extrusion technology, advanced polymer blends, flame retardant materials, and biophilic composites. We also have Ramesh Balasubramanian, a Senior Manager of Application Development at Steer. Ramesh is a seasoned professional with more than 15 years of expertise in extrusion techniques, process mapping, and product development. A graduate in Polymer Science and Technology and has worked with industry leaders like Reikan, Huasan Materials, ALP Nishikawa, Prince Pipes, and Wilson. At Steer, he plays a key role in advancing twin screw extrusion technology and enhancing process productivity and has been instrumental in several key innovations. Thank you, Dr. Prakash and Ramesh, for being here with us today. We are looking forward to a very highly engaging and insightful session. Now, I'd like to hand it over to Dr. Prakash to kick off today's discussion.
Hi, everyone, again. Steer had 4 application development center. One is in Bangalore facility in India. It's a headquarters. And we have China, Japan, and USA. This is a Bangalore facility. What we have? We have Omega, Mega, extruders to support customer and also to test the raw materials and also understand the behavior of the polymer and the characterization. Steer America has Omega 30 extruder, and we have all the peripheral to support customer. Steer Japan have 30mm extruder, and we have all the support to test the polymer characteristics and also trial run on the facility. And it had a longer LOD of 70. Depending on the application, this length can be adjusted. Steer China ADC, we have 40mm extruder, and it had all the facility with the peripherals of feeders, gravimetric feeder, underwater pelletizer, strand cutting. Polymer Dynamics Center facility has enabled accreditation and to support customer to understand the testing and characterization of the polymers compounds. We'll first discuss on the degradation of polymers. Why the degradation of polymers? We are day-to-day activities. We are using polymers for most of the applications. And when you use polymers, we put it in the twin screw extruder, the polymer behavior changes. When you apply heat, it melts and the behavior changes. When you cool down, the behavior of the polymer changes. And what is the behavior changes when you apply higher temperature inside the vessel? When you increase more heating, thermally degradation happens on the polymer behavior. Second, shearing action. If you apply more shear or if you applying harder screw design, the polymer behavior changes. Mechanical degradation means it loses its molecular weight. It breaks into smaller and smaller. If you put hardened screw design and higher RPM, by that time, sometimes if you apply more than 1200 RPM or less 500 RPM, depends on the applications. This shearing action, we call it as mechanically degradation. Oxygen and ozone chemical degradation, we call about when your polymer exposed to the oxygen. Because when you are feeding your ingredients with the polymer into the extruder, it takes oxygen along with the polymers. If it goes and melts inside the vessel, you're losing its property because the chemical degradation is happening. It changes the color, sometimes yellow color, and loses mechanical property. And also chain session, we call it as. To avoid that, to resistance, we need to have additives, stabilizers, and also chemical resistance additives has to be used. And electromechanical UV, light induced degradation. And lastly, the moisture. Some of the polymers having hygroscopic in nature, and we call it as a hydrolysis. It loses its property, chain session will take place. If you put the polymer in the environment, all the action like shearing action or shear, heat, UV, and the moisture and the ozone, all will attack to the polymer, and the polymer loses its property. For example, the example what we have given here, HDPE. HDPE start losing its for over a year. It starts using its property. How to protect that? To protect those polymers, we need to have additives. Without additives, there is no polymer stable. To stable your polymer, additive is a must to use. Now, today we are going to discuss fundamentals of pigments and what is the behavior of the pigments, how it is sensitive, the pigments. If you broadly classify the pigments, inorganic pigments, this is inorganic pigments, and there are classic organic pigments and high performance organic pigments. There are three categories. If you divide in terms of properties of each pigments, if you say color and the purity of the pigments, most of the inorganic pigments dull in nature. Means inorganic pigments, if you example TiO2 and red oxide, these are all inorganic. There are many. I'm naming only two. And when it comes to the organic pigments, many are there. Phthalopigments, azopigments, these are all organic pigments. If you talk about blue, green, red, many of them. And when you talk about the color and the purity, the organic pigments are brighter in nature, both high performance organic and also classical organic pigments. When it comes to the opacity, inorganic pigments higher opacity, and classical or organic pigment opacity in terms of transparency is higher in the organic pigments. Color strength is an important role of the mechanical property. The color strength of inorganic pigment is medium and the color strength of the organic pigment is higher in the both the cases. Heat resistance, if it talks about the each pigment, the inorganic pigments will withstand or it will withstand more than 500 degrees centigrade. But in the case of classical organic pigments, it will withstand 150 to 220 degrees centigrade. And in the case of high performance organic pigments, 200 to 300 degrees centigrades. We need to select the pigment depending on the requirement. When you are applying shear inside the screw, you have to select the pigments. For example, if you select the pigment of 150 to 220, like classic organic pigments, and if you are applying higher shear rate, then it loses its property. Means you are degrading your pigments in the vessel itself, in the twin screw itself. We need to understand the behavior of the pigment, select the pigment. Resistance to chemical varies in the inorganic pigments and high in the organic pigments. Most of the organic pigments highly resistant to a chemical. Organic pigments, now we are talking about organic dry powder pigments. Now, why dry organic pigments are difficult to disperse? Yes, there is a chemical structure and the phenomena. Organic color pigments are difficult to disperse due to strong covalent bond in the pigments, carbon and hydrogen. When you break this bond, you need to apply high shear. You need to apply high energy to break the bond. That is why it's difficult to disperse organic pigments. Even organic pigments difficult to disperse in the non-polar polymers. Who are those? Polyethylene, polypropylene. These are the polymers are non-polar. To compatible with non-polar polymers and the pigments, we need to use the wetting agents or waxes. Why do you need waxes? Because when you use a dry pigments are tendency to re-agglomerate, because when it comes to the exposure of the moisture, it trying to re-agglomerate. So that to break the agglomerated particles, again we are using more than 10% of waxes to wet the pigments. And also PP and polyethylenes are a non-polar. It is not compatible. To mix it, we need to use a waxes. It is again the additional cost using the waxes, especially in the dry pigments. And to break the dry pigments, agglomerated particle, what is the method to use? There is the only method, use the kneading block to break the particles into smaller and smaller. Then again, you're applying more energy to break the particles. To get dispersion and distribution, you are using kneading blocks. To reduce the particle using kneading block. It is again a cost. Now, physical form of the pigments, what is that? When you say primary particles or the pigments, is it most of the pigments are in round shape? No. Sometimes the pigments will be cubic form, spherical form, round like rods, okay, and flake forms, sometimes irregular in shape. There is no shape, like it is like an irregular shape. Most of the pigments are in the regular shape. Again, in the particle size of the pigment history, we categorize agglomerated particles, we call it agglomerates, right? Aggregates, these two phenomena. Agglomerates are tendency to when this particle, if you see the particle and this particle attach, join in the corner, not attached to the surface. Agglomerated particles attach to the corner or at the angle. Only in the angle it is attached and it's easy to disperse. Agglomerated particle, it's easy to disperse because some of the pigments is not hygroscopic in nature, some of them highly hygroscopic in nature. And if heat and moisture come into play, the pigments tend to agglomerate. The particle joins corner and edges is loosely bound arrangement so that it's easy to disperse. When in the case of aggregates, if the aggregate particles are joined together on the surface, see, each pigment is on the surface, it's completely bind together on the surface, it's difficult to disperse, it is difficult to size reduction. We need to apply more energy to break these aggregates. This is the only two difference in the pigment, agglomerates and aggregates. In the dry pigments, again, how we can wet each pigment? Each pigment has to be wetted thoroughly so that the dry pigment has to be mixed in the polymer. How to wet the pigments? The pigments dispersion depends on your particle size or a coarse size or a small fine size of the particle surface area. When the surface area is very, very important. And surface charges, again the polarity on the surface, again compatibility of the pigments with the polymer. It has to be compatible. If you're using non-polar polymers, again you need to find out the compatibility to bind together. What is happening? When the pigments start wetting on each particle side, this one, the bigger one is the pigment, the waxes. This waxes start coating on the agglomerated particles. This is the agglomerates particles. When you apply waxes, again, this agglomerates has to be dispersed. It has to be break down into smaller. We are using kneading blocks. We are again applying more energy to break these bonds. Breaking the agglomerates into the smaller particles, we are using this phenomena called dispersion. Again, each pigment coated with the waxes, we call it as a wetting phenomena. This is the wax coating onto the pigment. It is called wetting mechanism or a wetting phenomena. Once the dispersion is done, again, we are distributing each pigment, because once a pigment is coated on each particle, that pigment has to mix together with the polymer, and this has to be distributed evenly with the polymer and the pigments. We call it a homogeneous mixing. Three main factors impact of the dispersion. If someone saying, okay, I'm not getting a good dispersion, there are many reasons you're not getting the dispersion. Maybe your pigment has agglomerated particles. To break that, to get the dispersion, you need to add waxes and you need to get compatibilizer. Then only you can get the better dispersion. To get the dispersion, you need to have an extruder, twin screw extruder. In the twin screw extruder, you need to have a screw speed. Sometimes higher the screw speed, better the dispersion. Depends on the nature of the pigment. When the pigments agglomeration has to be break down, so that you need to have a wax and all the ingredients. Again, temperature play important role. Your screw configuration, also matters. Screw configuration depends on your pigment. You need to adjust the screw configuration. If your pigment is very sensitive, you apply a screw design, you made a screw design harder, then you're destroying your pigments. Everybody calls that my pigment started re-agglomerating. It is because of this. If you are applying more pressure, more shear on the particular pigment, how much pigment shear it needed, we need to calculate and have to apply. Again, whether you have a premix method or a split method, this is a feeding method. You need to select which method is the best method for us to get the better dispersion. Formulation play a vital role. Your polymer, additive, how much additives you are using, and also selection of the pigment important to get better dispersion. What is dispersion and distribution? When the dispersion and distribution, if you see here, the solid air, where the air comes from? Air comes from the environment. When you combine two particles together, air entrapment. In between the two particles, air entrapment. Then again your solid and air and your powder put together form as agglomerate. In between, because agglomerate, right? Then the two agglomerates, again there is a air pocket. You need to destroy the air pocket. That is air solid interface, we call it as. In this case, this is the agglomerated particles. Here is a blue and yellow. If you disperse by using kneading block, blue pigment and yellow pigment was separate out, two half. Then again, these blue and yellow has to be mixed together. That is a mechanism we call it as a distribution. The first one, breaking agglomerates into smaller and smaller, we call it as a dispersion mixing. Distributing these two color to get a homogeneous mixing, we call a distributive mixing, because your polymer and your pigment has to be distributed evenly in the poly. In this form, that is called homogeneous mixing. I have put wider kneading block here. This is a screw design like kneading block. Sometimes when you use wider kneading block, give better dispersion. It is a tendency to break the particle smaller and smaller, that we call it as a dispersion. And the thin kneading, we call it as a narrow thin kneading, call it as a distributive mixing. It depends on the pigments. You need to select the screws. But when you are using wider kneading to break the particles, you are using more energy to break the particles into the dispersion mode. Because that is a tendency of the dry pigments to get agglomerate. What are the process challenges when you use in the color master batch? Feed limitation. What is feed limitation talks about? When you premix the pigment and polymer, pigment having a tendency to, means the low bulk density pigments, it try to settle down in your hopper, and that we call it as a feed limitation. It's hopper flooding, we call it as. Later, we talks about pigment wetting. You take your wax and you take your pigments, all the waxes has to coated into the pigments. That is, we call it as a pigment wetting. If the pigment is and the wax is not wetted properly, that is also a process challenge. Sometimes one particular pigment coated with the wet like a waxes and other pigment not, then you don't get the proper dispersion. Each particle behave in a different way. This particular particle disperse properly and this is not. Because if you are wetting each pigment, then your dispersion will be good, and also there is a less wear and tear on your screws. if you are not using a proper wetting agent on the pigment, there may be chances of wear and tear on the extruder and shear rate will increase. Then again, you are going to break the pigment particles. In the sense degradation, we call it as, if you apply so much shade, it's a degradation. And dispersion of the pigment play a vital role. It all depends on your screw design and the formulation. Distribution also, your selection of the kneading block, and frequent color changes leading to discoloration mean 1 hour before you are running red color, after that you are going to change the color. Small traces of color lead to discoloration of the your final compound.
We have just launched a poll question which will be visible on your screen. Just kindly share your answers. Yes, Dr. Prakash, we can see that a significant majority of the audience find that organic pigments are more difficult to disperse.
Yeah. Thank you. Okay. Since currently the industry using traditional method, what is the traditional method? You are putting polymer, waxes, and other ingredients, and you premix 100% premix in high-speed mixture, and you are dumped into the volumetric feeder or a gravimetric feeder. From there, you're discharging through the hopper, and then the dispersion distribution takes place inside the extruder vessel and devolatilizing, and this strands will be quenched into the water, and then the surface of the water, strand surface of the water removed from air knife, and then pelletizing will be done. This is the current standard traditional method everybody is following. There are drawbacks. What are the drawbacks? Currently, the industry is struggling. One is to breaking the agglomerated particle into smaller, and because the dispersion, you're putting so much waxing, we are adding so much, we are spending money on that. Second thing is we are putting so much energy to distribute or disperse the pigments. We are applying harder screw design to break the particle. These two areas, again, the dusty environment. If you go to the shop floor, after 1 hour, when I come back, all the colors on my head, right? That is a dusty environment. This is dry pigment currently, industry is struggling. To overcome this issue, Steer has introduced a new technology. We call it as a wet pigment technology. To overcome this, we have a wet pigment color master batch. Why do you need a wet pigment cake with the color master batch? It helps you the superior dispersion compared to the your dry pigments and uniform color distribution, and also high color strength. Because in the dry pigment, if you apply high shade, you're losing a high color strength. In this case of the wet pigment, you can retain the high color strength and cost saving, cost efficient. Wet pigment dispersion. Here, this is the wet pigment. It combined with polymer, powder, and the pigment and 60 to 70% of water in this mass. Currently, yes, if you take this, it's difficult to feed. It's a lump. And how to feed it? Okay, that's a big challenge. To overcome this challenge for a wet pigment, Steer had introduced a new technology so that we call it the feeding mechanism to feed the wet pigment into the extruder. When you take this wet pigment from the manufacturer, it combines pigments and water. 60% of the water and remaining 40% of your pigment. What is going to happen here? It's easy to disperse because when this is your pigment, this is water surface in the outside. When the pigment in the water media, it's liquid to solid interface. And when you disperse the particle, it will not form as an agglomerate. The moment if you remove water from the media, it will tend to re-agglomerate or agglomerate. But if you keep this into the liquid mode with the polymer and when we disperse, and the later you should dewatering mechanism to remove the water from the system, that we call it disperse into the liquid media. That is the difference between dry pigments and the wet pigments. See, traditional wet pigment and currently the traditional and the wet pigment color master batch compounding process. The top one, we get the pigment synthesize and also precipitation and filtration. These two area. Then after this, we neutralize your pigments with the water, adjusted that. This after washing the pigment and water, 60 to 70% of water and remaining 40% of the pigment or sometimes 30% of the pigment in this mass of the wet. If you take out from here, then you can straight away put it to your twin screw and using steer feeding mechanism, also dewatering so that your job is done. You can save energy and your dispersion quality is fantastic. But what currently we are doing traditionally, we are doing after the washing, we flush. Once the flush process is done, we are drying this. Again, we are putting energy. I don't know how many hours we are spending on this. And once the drying is done, we have to grind it into the required particle size. Grinding and milling has to be done. When this phenomena done, later that pigment and a polymer and a wax, we pre-blend or pre-mix in the high-speed mixer and put it in the tin screw extruder. Again, we used to have apply energy, more energy. Waxes, we have to use more than 10 to 15% of wax along with polymer to break the particles of the pigments. And it takes more time to disperse, right? And then once the melting is done, disperse distribution is done on the color master batch, we have to cool down and using air knife, remove all the moisture and pelletize. Downstage, we are using straight away the wet pigments is along with the water 60%. And what we did, we take the polymer, pre-blended, and we use steer feeding mechanism to push to the twin screw extruder. Once the twin screw inside, we devolatilization means dewatering in the 3 location of all 60% of water. Once this is done, dispersion will be done in the same stage. After that, same as a traditional method, quenching, your strand cooling will be done and then pelletizing. But if you compare both pellets of the dry pigments, color master batch and the wet pigment, there's a lot of difference. the dispersion value is almost 2 times higher, better than your traditional dry pigment compound. Here, left-hand side, if you see dry pigments, there are agglomerate particles. And it's a wet pigments. We didn't find any agglomerate particles. It had already water in that. Dry pigments, free flowing, but wet pigments, hard to flow, right? You have to use another mechanism to push into the extruder. It's a feeding mechanism. We have a solution for that. And if you use a feeding mechanism, you can increase your throughput and also lower SME, lower specific mechanical energy. In the dry pigments, it pour to disperse, and in the wet pigments, efficient pigment dispersion. And the dry pigments, you have dusty environment, and in the case of wet pigment, no dusty environment. And the pigments agglomerated particles more in the case of dry pigments. Here, reduce agglomerates or no agglomerates pigments in the wet pigments. Poor color strength, when you use a dry pigments, I already explained why the poor color strength, because you are using higher kneading block and you are destroying the pigments. In terms of wet pigments, higher color strength, because it retains a color strength, because it is not destroying your pigments. High energy usage in the dry pigments. Again, in the wet pigment, lower energy, higher output. In the case of dry pigments, you have to use lower output to get the better dispersion. Here, you need to require waxes in the dry pigments, no waxes required in the wet pigments. Now, we are discussing for the case studies. We have used twin screw extruder omega 40H class, DOVDI 1.71. Because it had 60% of water, we have selected DOVDI 1.71. The reason for that, you need higher free volume so that you can more water, it will withstand, so that higher free volume will be discharged better way, and also dewatering will be done in the faster manner. This is a nominal torque, 550 Newton meter, power used for 135 kilowatt motor. Feeding material, we have used special feeding mechanism to feed your wet pigments. And the feeding system, all 100% premix with the polymer. Polymer 43%, the pigment with the water is almost 57%. And we have used downstream water bath, air knife, and the pelletizing system. This is schematic, not actually. And what we are doing, we are weighing all the ingredients and you put it in high speed mixture. And that from there, we transfer that materials to our feeding mechanism here, and it will feed and push into the twin screw extruder. The water removal will be done because of dry vacuums, water removal in 3 locations, and then stranding and a pelletizing will be done. I'll show you just small trial on the wet pigments video. See, once a premixing is done, we are feeding the complete 100% premix material into the hopper. We are dewatering your all 60% of water from there, and this is stranding, and then it is a finally yellow green pigments disperse and shining. No waxes used in these. If you compare traditional standard dry pigments, if you see the particle size, if you see still rough surface on the surface, and again when you see the surface of the pellets, some green color you can visible on that dry green pigments. You can see there on that. This is again 40% use dry pigments with LLDPE. This is a palette. And if you see the right hand side, LLDPE, 40% Masterbatch green pigment, wet pigments. And when you see the palettes, smooth, rough surface and shiny surface, no additives, no waxes used in this. And if you see the surface, it was completely dispersed pigment into the polymer matrix. We also did the blown film. We didn't find any agglomerated particles in the blown film. The filter pressure value, in the left hand side, we have used same 40% dry pigments LLDP, and we observed the filter pressure value 2.1 bar per gram. Use 10 micron in that, and the wet pigment showing 0.72. Okay, 0.72 filter pressure value using 40% green wet pigment with the LLDPE. What are the key points? Test condition, we have used 10 micron and dry pigments 40, filter pressure value showing 2.1 bar per gram. What did we observe? Higher pressure build up on the screen or the filter due to the poor dispersion and agglomerates. We can visibly see that. In the wet pigment, we observed filter pressure value 0.72 bar per gram, low pressure indication, better dispersion and uniform pigment dispersion. And finally, we decided wet pigment process advantage, reduce mesh blocking or my filtration blocking, improve dispersion quality and consistent color strength on that. In this case study, we have used two. One is a green 7 pigments, and also we have used yellow pigments. Yellow pigments, we have used 30% of the pigment and 70% of water in the mixture of the pigments. And we also followed the same process, pre-mixing polymer, wet pigment premix, fed into the twin screw extruder using special feeding mechanism. And then we use dispersion and also dewatering of 70% of water from the extruder. And we have taken the pellets. We observed quite dispersed shiny pellets. And this is the blown film. From the left hand side, we didn't observe any agglomerated particles in the blown film. We also tested filter pressure value. The left hand side, same 30% pigments with LLDP, dry pigment showing 1.29 bar per gram, and the same we use for a wet pigments, we observe 0.58 bar per gram. Here also we observe when you use yellow pigments, higher pressure buildup and poor dispersion and agglomerates. Again, the wet pigments we use 0.58 bar per gram, and similarly lower pressure, it indicates better dispersion. And we reduce mesh blocking, improve dispersion quality and consistent color strength in the yellow pigments also. When you did the calculation, we have taken one batch, total batch of LLDP 64 kgs, and your pigments and the water mixed together. It's a wet pigment, 85 kg, total put together 149 kg is a batch. Finally, what did we have collected water and material separately, and we understood how much is the loss and all. There is no loss. We have removed water completely. The sample collection is 106 kg. In the first port, we are able to remove 31.5 kg of water removal. The same water can be you can recycle and reuse. Again, for once you water treatment, that can be used for your plants, or you can reuse for again for your regular usages, the same water. There's no waste in the water, that can be filter it out and use it. In the moisture, water can be collected in the second port 8 kg. And finally, the traces of a volatiles has removed through the vacuum stuffer 0.5 kg. And water removal is almost 40 kg from the system. After doing the experiment, we validate what is important using wet pigments. When you use a wet pigment, faster dispersion mixing. When you use wet pigments, demonstrated a 20% higher and the faster rate of mixing compared to your dry pigments. When in the case of, again, what's the improvement on the color strength? 15% higher color strength compared to the dry pigments. And 10 to almost 8 to 10% of energy saving compared to the dry pigment. When you use wet pigments, these are the advantage. Wet pigments lead to faster dispersion and better mixing, improved color strength, and also lower specific mechanical energy, and also better distribution of the pigments in the polymer matrix. When we compare the dispersion quality, the dry pigment versus wet pigment, when we are using dry pigment, inconsistent of your pigments, dispersion, excellent and uniform dispersion in the wet pigments. Processing time is longer in the dry pigments, faster in the wet pigments. Dust handling is risky and higher, so that your plant will be completely in hazardous nature, so that it will be dust. Minimal dust in your wet pigments, you can minimize lot. And the wax requirement is needed in the dry system, but in the case of wet pigment, not required. Color strength moderate in the dry pigments, superior in the wet pigments. The processing cost moderate in this. The cost efficient waxes saving the wet pigments. When you consider using wet pigment, what are the economics and environmental advantage using our wet pigments? Economic advantage, cost saving on using additives. In the wet pigment, we are not at all using additives, so that is a one costing for you. Reduce processing time. If you finish faster of your pigments and dispersion, increase strength and everything. So that is a one more advantage, additional advantage for you. Improved efficiency of the dispersion quality. That is the third one advantage. Higher color strength, or the fourth one is the additional advantage. Lower maintenance cost is the last one, is very, very important. Your maintenance cost will be lower. Your dries will not be dusty. No dust sitting on your dry. You don't lose any dries, and you can maintain clean, neat environment your factory. Environmental advantage, reduce dust emission. And because everywhere is the dust, then how to clean it? You need to use many manpower to clean it every day, and water wastage has to be done. And lower energy consumption, you are using low energy, reduce dusting, low energy. Sometimes the waste reduction happens using dry pigments. In the wet pigment, no wastages, eco-friendly processing, cleaner production environment. When you are using, these are the environmental advantages. These are the economic advantages. Finally, in the summary, the finding is dry pigment involve more complex and processing methods. You have to use waxes, premixing, a dusty environment, and require high energy inputs to dry and disperse your pigments. Wet pigments provide easy method and better dispersion, higher throughput, and your lower dust and hazardous in your nature. And the wet pigments is high quality dispersion you can use. What we recommend to go for the wet pigments, steer support is always with the customer. We need to support the customer. We have a feeding mechanism to also get how to get the dispersion of the pigment. And we also have a technology to support customer, and their advantage can lead to improve your productivity and minimize health risk. The dust will uh, again will risky on your health for the your operation setting. I think I will end this session. Thank you so much, guys, for listening, patiently listening. Yeah, now over to Swaroop now.
Thank you, Dr. Prakash, for this really wonderful session. I hope our audience were able to gather some key insights into the advantages of a wet cake pigments and how they can improve their process efficiency. I now open the forum for any question and answers. Kindly drop in your questions in the chat box and our experts will address them. Dr. Prakash, we have one question here. It says, what modification is needed in the existing system to adapt for the wet pigments?
Yeah, good question. The current system is made for dry pigments. If you want to try to change the existing system, there are a lot of modification needed. So that again, same cost of the new extruder. Steer will not support you on that. In the sense, it's not advisable to change the existing system, because in the existing system doesn't have a dewatering system. And also there is a feeding system, separate feeding system and dewatering and the complete screw design. Maybe you can utilize the downstream equipments, what currently system you have. That can be used. Vacuum you can use, but dewatering system you cannot use for the existing, you don't have in the existing. So that we recommend to the user or customer, go for a new one so that we can support you on that.
Thank you, Dr. Prakash. Second question is, there is a problem with water sensitive polymers like PET. Would adding of wet pigment cause hydrolysis?
Yes. When you are using PET, it's hygroscopic in nature. PET always tendency to it change session, we call it as. The moment it attack to the water, it change session it takes place and loses its IV. We call it inherent viscosity. It loses its molecular weight and IV. Moisture is not good for a PET. Moisture is a killer for that. So that yes, you loses your IV on using PET when it combined with the water.
Our next question is, are there any safety concerns during the water removal stage?
No safety concern, because water removal, we have a separate system. It's completely covered. what you have seen just now with the video, it is for the experiment purpose. Yes, when you are supplying the system, it will be completely covered so that there will not be any spillage of water outside. It will be collected in a separate barrel, separate vessels, so that it can segregate and it can be reused, and you can again you can treatment. The water treatment can be done in the later. Yes, his question is vital because his concern is after seeing the video, he said how we can handle this water. Yes, only for the demonstration purpose and the lab we have done that. It's enclosed completely, no spillage of water.
And our next question is this process applicable for carbon black as well?
Yes, it's applicable for all the pigments, not only carbon black. If you are using blue, green, the only example what we have taken is green, yellow, green 7, and also yellow pigment. These two. Yes, it's applicable for the carbon black also.
And a similar question, is this applicable for engineering polymers based master batches as well?
What is the difference in engineering master batch pigments? We are talking on the pigments now, because pigments is again you have to synthesize, you get the pigments. Whether you are engineering polymer, whether you are polyolefins, the polymer is same, right? When the pigment changes, like if you are selected the pigments of depending on the your melting point. For example, stability. The pigment, some of the pigments stable at 150 to 200 degree. If you use those pigments in your engineering polymer, your polymer starts melting at 250 to 300 degrees centigrade. There may be chances of your pigment degradation. But if you are using above 300 degree, then we can use the same particular pigments in the your engineering polymer also. That's possible.
Thank you, Dr. Prakash.
You're most welcome.
The next question is the two-part question. How do we get this wet pigment? And how do we get this mixture of wet pigment and the polymer to be a slurry?
Yes. See, what I have seen, it is not like a slurry. Wet pigment having 70% in the water because it absorbs. The water is there. It is not 100% slurry. Okay. It is not free flowing, but you can say it is like a wetty form. What normally we do and take that wet mass and you mix with the polymer, and then it is not free flowing and it's difficult to feed into the twin screw extruder. That's why we find out a mechanism so that it can feed properly into the twin screw extruder. You need to have a separate feeding mechanism to feed this particular wet pigments into the your twin screw extruder. Yeah, thank you.
And Dr. Prakash, you have answered this earlier, but I think probably a little more clarity. For somebody who is using dry pigments presently, can they wet it with water and use it?
Sorry, come again.
For somebody whose present process is using a dry pigments,
Yes.
Can they wet their dry pigments with water and use this?
It's a great question. It's tricky to answer. Yes, if we tried this in our lab, if you use this water into the dry pigments, but difficult to change the morphology or the form, the morphology of the pigments, because you need to put too much water and make into the slurry form, break those particles into the water first. Then you have to feed into the twin screw extruder. But if you are just wetting water like a 10% or 20% into the dry pigment, but agglomerated particles still there, and no matter you disperse, then you don't get the dispersion quality. This is what we tried in our lab. Yes, it is not succeeded. I mean, you can avoid dusting, you can avoid other things. The feedable form is easy, but end of the day, the dispersion quality will be poorer.
Interesting.
Yeah.
Yeah. And the next question is, for the water that is removed, would it be clear or would it be colored?
Yeah. Initially, some traces will be still in the colored, not 100% colored. That's why we need to use a filtration so that you can filter the water before it go into the collection. We have a filtration system to filter it. Every 3 hours, 4 hours, that filter has to be removed. Regular filters, not the fancy filters. We use a regular filter to change it. Filtration needed.
Our next question is this wet pigmentation process suitable for both batch method and continuous method?
Currently, what we are targeting is a continuous method. When you are batch method, again, batch method where you are mixing and putting it to the kneader. That I consider as a batch technology. Batch technology means you mix in the kneader, put into the again twin screw or a single screw. That is a batch. Yes, possible. I'm not sure how we can get the dispersion quality, but when you are going for a batch mixer, again it is handling, feeding is in a big mesh. Again, you are spoiling your completely shop floor. Then dispersion looks like poorer because again depends on your screw design what you use. Again, how do you dewatering? In the batch process, I'm not sure how you are dewatering the water from the system. What currently you are doing in the mixture, you are adding and you are evaporating the water first. Again, there may be chances of agglomeration. Okay, the moment if you remove the water, chances of agglomeration. We insist continuous process so that is easy to handle and maintain your shop floor cleanly. Yeah.
Yeah, and Dr. Prakash, another similar question. Uh, how about the pigment wetting process itself? Would this be in a batch method or a continuous method?
Wet pigment currently up to the manufacturer in the batch process. When it takes wet pigments, in the sense you do synthesis, then filtration, and then you match the neutralizing of the pigments and everything, match the water content required. That is called the wet. From there, we take into the twin screw. Okay. And that method, when you take it to the twin screw, that it is a continuous method. Currently, up to the traditional method is still in the batch process. But even up to the wet pigment, it's a batch process. There is no continuous process.
Another question. If you can also a little elaborate on how the wet pigmentation process resolves the reagglomeration issues found in dry inorganic pigments.
See, dry inorganic pigments, because it's a tendency of agglomeration, but inorganic polymers, I don't face any issues on the dispersion level because inorganic easy to disperse because of their carbon and hydrogen chain. It's easy to disperse and not like organic pigments. Organic pigment difficult to disperse. Inorganic is much easier to disperse, but inorganic we never tried on the wet form. But if you have wet form, inorganic pigment, bring it to us. We can support you on that. Currently, we are not handling the inorganic pigments in the wet form.
The next question, doctor, is will this wet pigment process affect the delta E value or AB values of the colors?
Yes, that calculation is done already. Delta V value. It is almost nearer. It was good one, but I could not able to share now currently. Maybe if they are interested, they can discuss with us, and then we can share the delta value with them.
Okay, doctor, the next question. Whether wet pigments are better for dispersion due to disbursement like wax?
Sorry, can I come again?
Means what they are asking is whether the wet pigment dispersion is good because of the dispersing agent like wax.
No, wet pigments, we are not at all using waxes because your water is a media, it helps you to lubricate. When the wet pigments with the water, see, what's the problem when you remove the water from the pigment and it become dried and reagglomerates. Right? If you are keeping water and the pigments together in the same surface, then you don't need a wax. Your water is act as a lubricant. You don't need waxes for the wet pigment. You get better dispersion.
And the next question, doctor, is what is likely to be the final moisture content after completion of the process?
Moisture content, when we tested, it is 0.2%. Is there any other question?
Yes, doctor. The last question is, into which working zone of the extruder should a prepared solution be added?
That we'll discuss one-to-one when they are showing interest. Definitely we'll discuss with them which zone we have fed and which zone we are dewatering, which zone we are going to disperse. Definitely we'll discuss with them.
Okay, doctor.
Thank you.
Yeah, I think that's all we have questions. If you have any more questions or any other comments or feedback, please drop in your comments at the email ID that is seen on screen. Yeah, thank you. I once again thank everyone for joining us. I hope this was a very informative session for you, and we look forward to seeing you in our upcoming webinars. Thank you
Thanks so much.
and have a great day.
Bye bye.